So, might as well get started on that. So, yesterday, we did a number of examples of file I/O, and we just got briefly into the first bits about date formats. Unfortunately, the camera ran out of juice for the last 15 minutes of class, so I'm afraid that information is lost to history. But I hadn't really said, that much. It was interesting, I think, but not going to be on the test or anything. So, if that's your metric for such things, then you didn't miss anything. But yeah. So the question that we have, the question we're attempting to answer with this particular. Oh, I should use the microphone. Sorry, give me a second. Pardon me. Testing, testing. There we go. Perfect. So, the question that we're attempting to answer in this set of slides is, how does one work with time? All right. Now, fortunately, there is a library in Python which allows us to work with time relatively easily. That is, we don't have to re-implement a bunch of stuff. However, the reason that it's useful to have a library for this sort of thing is that time itself is a fairly complicated thing to keep track of. Last time in lecture, we were talking about all of the various ways time is represented across the world, including this particular chart, which indicates which date formats are used in particular parts of the world. Now, you may be saying to yourself, now, while these are different orderings of the same information is present in all of these cases, so how could it possibly make any difference, whether you're using year, month, day, or month, day, year? Well, the problem, of course, comes when we are trying to get a computer to interpret this data for us. You'll not have been paying very close attention in this course if you think that it's, you can just type a few lines and it just easily, magically comes. Well, you do have to type a few lines, but, these things don't occur automatically. If you have an algorithm which expects date to be written day, month, year, and it's provided values that are month, day, year, then you're looking at minimally a value error. In any event, your algorithm is unlikely to work unless it has specifically accounted for the fact that months, days, and years can be represented in many different orders. So the question then becomes, how particularly does Python represent all of these values? And of course, after having covered topic 8, the answer will obviously be using classes. We will have a date time class which has fields inside of it which represent the year, the month, the day, the hour, the minute, the second, and the millisecond. Fairly straightforwardly. So, the datetime module provides classes to represent dates and times and to manipulate them. So we have the date-time object. We have two sub-objects within the date-time object, both date and time. Date-time, as you might expect, is a representation of both date and time, whereas datetime.date represents specifically dates, datetime.time represents specifically times of day. So it's sort of split along that. So datetime.date represents dates in the Gregorian calendar system, which of course is the one that is most popularly used internationally and in North America particularly, in Canada specifically. It's rare to see a calendar system other than the Gregorian calendar that's not in some way associated with horoscopes. The time aspect records hours, minutes, seconds, microseconds, sorry, not milliseconds, microseconds, and time zone. Oh, actually, I think that might be a typo. I think it is milliseconds. Datetime, datetime.datetime, is a class representing a date and a time on that date. And most interestingly, we also have a class for a so-called time delta. So how many of you are science students? Science, what faculty are you from?
Engineering.
Engineering. So all of you will know what a delta is, right? It's the difference between two values. Delta being the Greek letter. So like the question is, right? If you're trying to represent the difference between 2 points in time, what date would that have? Right? It doesn't make any sense to ask the question. There's, basically, and this is a very computer science way of saying this, there's a difference between the relative and absolute addressing of temporal position. The date, time, and datetime libraries are all absolute positioning within the temporal space. The time delta is a relative position inside of temporal space. It's a relative position that has been decoupled from the time that it is relative to. So, if you're trying to perform some kind of calculation, for example, if you're trying to figure out from absolute dates how many hours you have to spend at the airport, the result that you get is going to be a time delta rather than an absolute time, right? It's like I have to spend 8 hours, 53 minutes. That's a time delta. Make sense? Good. Time delta objects are the automatic result of subtraction operations on dates. So if you were trying to find the difference between two dates, you use subtraction. That results in a time delta. Time deltas may then be added to other absolutely addressed dates and times to find, the actual time that you would you would leave the airport. If the time delta is the amount of time you have to spend in the airport and you know your time of arrival. So, this is how we work with datetime objects in Python. I'm going to call up a terminal and we'll have this as a programming example in our usual fashion. Wow, this is actually a class of 3 people. I was like, well, maybe some people are actually running late, Maybe we'll have a few more people arrive, like happened yesterday, but no. There are 4 people in this room. It's amazing. I think this is a record for me, actually. This is record low attendance. Of course, last I heard, fully half of the class had dropped the course after the midterm, so. Anyway, so from date time, import date time. There we go. We can also do this neat, I think I've shown you this before, but you can also use as to rename the thing so that you don't have to type out date time every time. We can rename it D, and then we can say d.now is a date time object representing the current time in temporal space. So you can see that it is currently the year 2022, 6th month, 7th day, 9th hour, 44th minute, 48th second as of the calling of the function. And then, I guess it is microseconds, isn't it? There we go. So, hey, the class expands by 33%. There we go. So, we can also create times, rather than just polling the current time, by using whichever date values we wish as arguments to the constructor of the date time object. So, we could say something like, my defense is date, or D, 2022, 6/27, 14, 0, 0. And then we get the exact position in temporal space when I'm going to be defending my PhD thesis. If we want to find out the temporal displacement that represents current relative to the current time, we could say something like time left for slides left to make slides is equal to datetime.now. Well, actually, you would do my defense subtract datetime.now. So, I have 20 days, 15,176 seconds, and some number of microseconds, which means I should get the heck at it. So, any questions about that? Pretty straightforward, right? Good. So let's talk about something slightly less straightforward. So I would like you to call back into your brain the discussions that we had about string formatting and formatting tags. So the Python datetime object is wonderful and comes with many things that are useful and many standard operations. But if you are reading dates in, for example, from a CSV file, which, one might imagine there are many applications where you would want to associate data in a database with time, you are more likely to find that time represented in the form of a string, because obviously a plain text file is not going to use Python objects inside of it. That's silly. It doesn't, it's not even possible. So the question then becomes, how does one convert from a string to a datetime object, and conversely, how does one convert from a datetime object to a string? Now it's slightly easier to convert from a datetime object to a string, so we'll do that one first. So, the strftime method is included in all datetime objects, and what that does is it's string format time. So this method produces as its result a string where that string is the date represented inside of the datetime object, or the date and time, formatted according to the format string which has been provided. Now, these format strings are going to have a number of these character groupings in them which represent the insertion of data, right? So this is a fairly common thing. This is sort of some of the old magic of programming. So if you have a string, right, anytime the % character is used, and this is like in the context of string, like a format string, this is a specific type of string called a format string. There's nothing inherent in the string that makes it a format string. Applying it in a manner that a program, like a function is accepting it as a format string, that's what makes a format string. But if you have % and then some character, depending on what that character is, you are selecting either the output representation of that number or the data that you are outputting, or both. In this case, both. So, as you might expect, capital Y, in this case, is a representation of the year. Lowercase m of the month, numerically, and lowercase d, the day, also numerically. Similarly, capital H is hours, capital M is minutes, and capital S is seconds. So, essentially, what happens here, we'll just do a short one, year and month, right? The algorithm which is performed on this format string, the string is scanned for format characters, right? This format character is encountered. It is replaced with the corresponding value found in the datetime object. So this becomes, say, 2022 dash %m. We then, from this point, continue to scan for format characters. Another is encountered. These two characters are replaced with whatever values are stored in the datetime object. So 2022-06. So there you go. Notice that the hyphen is left alone. Any character inside of the format string which is not directly a formatting tag is not operated on. It is left alone, it is skipped, right? So you can do pretty interesting things with that. You can put whole sentences in there. You can put any characters you want, really, so long as, you can even use capital Y, lowercase m, lowercase d, etc. It is the % which indicates it as a tag to be replaced. Otherwise, it will not be replaced. So, strf time. A format string might be something like y/m/d double dash you have h hours remaining. Oh, this is the time delta. So let's change that up. You have this days, comma, net hours remaining. Nope. Oh, time deltas don't have it. Well, that's so it goes. So, alright. My bad. strf time. We'll just, my god. strf time. There you go. So, the year, month, day, day, month, year representation of dates, as we described, differs according to the world, is brought into existence by the format string itself, and is not inherent to the datetime object. The datetime object's internal representation is irrelevant with respect to the manner in which that data is put forth into the world. So far as it goes. There are quite a large number of these format tags, other than those appearing specifically on this slide. If you want to take a look at the list, Python date time format tags. It's better for the, oh, come on. Don't freeze on me now. Jeez, there we go. Yeah, W3 schools probably got it. Yeah. So, as you can see, there's a large number of these, right? We've got day of the week spelled out, short version, long version, month name, short version, month name, long version, you know, full version year, full year without century, all kinds of stuff, right? So basically, I don't expect you to memorize these, obviously, but, you know, you should know, that this exists. And if you're looking for a specific date format, consult the table, right? Like you can even do what century it is and, you know, the number of days so far in the year which have elapsed. So, very cool. Good. Any questions about that? Yes? What's the difference between
using this and the regular string conversion?
Well, let's just see what's defined for it by running it, eh? So let's print. There we go. So, using the regular string conversion function results in actually the same format that's given on the slides here. We have year, month, day, hyphenated, and time with colons in between. The use of the string time method is if you want a date format other than this, right? This is what you get by default, but if you want anything different, then you're going to have to make it yourself. Does that make sense? Any other questions? Good. So, conversely, while we're, you know, while it's useful to be able to write date time objects in Python into files using this type of string formatting, it is also useful to be able to read strings and produce date time objects from them. So, if we use the strp time method, then we have access to that functionality. The P stands for parse. So string parse time. Parse, of course, is computer nerd lingo for reading strings and producing values from them. So, you'll notice, if you notice this comma, that we are provided here with two strings. The first string is the string which we are reading. And this may be a variable. This may be data that's been read in from a file. The second is another string, another format string. So format strings kind of work a bit differently in reverse. Essentially, what you're doing is you're creating a pattern which you intend the data you're reading to match, right? So, if the data that you're, or if the string you're reading uses, for example, abbreviated month name, December, for example, then you provide the corresponding %b tag. There is a space, you put a space. There is the day number, you use %b, comma, space, comma, space. You guys get the idea. It's important that you get the formatting right, because if you don't get the formatting right, you will trip an error. A string which doesn't fit the pattern that's provided will not be parsed, which will result in an error. Now, you know, these are the same sorts of errors that we can deal with using try except clauses, right? But, you know, so it's not necessarily absolutely necessary for you to know, you know, the precise date format that is being used in this particular example, like in the string that you're reading. Like the idea in an ideal circumstance is that the string that you're reading in will be read in from a file, and ideally you don't necessarily need to look at that file before you read the date in, right? So, you know, you could have it parse out from a number of possible date configurations. As if you're, you know, trying to parse it according to a number of different format strings, you can try except that, and that will that'll be an effective way of performing that. Make sense? Example time? So, let's say we have a string which is today is the 1st of April. It's not, but you know. We can say that the date is equal to datetime dot strp time. Today is the day number, st, of month. Oh, and then you also have to provide the string. There we go. So, that actually worked. If we view the date, you can see we got April 1st, 1900. So, the default value which is provided for year, if none is provided, is 1900, and the default values for hour, day, and hour, minute, second, pardon me, are all 0. Make sense? So, you know, it's pretty flexible. As you can see, you're not restricted to just reading in dates and times as represented like this. You can even read in whole sentences, right? The problem is that sentence has, like, your format string must match that second sentence. If you're even even one character off, then you get a value error, right? Value error, time data does not match format. So there you go. Any questions about any of that? Good. All right. So, I'd just like to talk briefly about time zones. Time zones are also very complicated. I'm sort of specifically designating this as non-testable material, so this is primarily for your edification, but yeah. So, time zones then. Time zones are very confusing, especially if you're not like a frequent international traveler. You have to be careful if you're dealing with dates or times that may involve multiple time zones. The internet has made it so that dealing with time zones is a much more prescient issue, because if you're having to make telephone calls or arrange meetings with people, in India, for example, it's it's very you have to understand what time it is there, obviously. So the date time object can have time zones set for them. So one of the parameters that it's possible to set inside the date time object is the time zone. So you then can convert between one time zone and another, sort of automatically using Python, which is kind of cool because time zones suck. So the recommended approach is to keep all Python datetime objects in UTC time, which is Universal Coordinated Time, I believe. And like UTC time is also equal to the time zone plus the +0 time zone, where the prime, like according to the prime meridian, which passes through Greenwich, England. Then, when you want to print that date, you convert to the relevant time zone at the time of printing. This way, your data is always stored in a way that makes sense to everyone, and you don't have to check what time zone you're in to convert to the time zone you're going to. You just convert. It's like absolute time zone addressing. You just convert to the correct relevant one at the time. The easiest thing to do is to use an external package, PyTZ, or TZ, I suppose, to help with time zones. This package can also handle daylight savings time, leap years, etc. So, there we go. So this is a complex example involving time zones that I would not expect you to replicate. From datetime, import both datetime and time delta. We also import PyTZ. Time zone is PyTZ.timezone, and then a time zone is specified, Canada Eastern, Eastern Standard Time. Basically, how the time zone library works is it has a bunch of internal time zone representations. You access them using, by specifying the time zone you want as a string. Many different strings will correspond to the same time zone, right? So it goes. We then specify a before time. So, we have some date, time zone info, is pytz.utc, specifying this as being in UTC time. 1 second is a time delta of 1 second. After is before plus 1 second. Our format string is, year, month, day, hour, minute, second, and then the time zone is specified. And then we print them. And I don't think I have got the output here. But yeah. At any rate, we need to be moving on. So, good. I think we'll just leave this more complicated example alone and move on to our next topic. Any questions about time zones or time in general? Any questions? Not at all? Not even slightly? Okay. So, let's talk visualization. So what do I mean when I say visualization? In this particular instance, I mean graphing. We're going to learn how to use Python to graph. Very good. In order to do so, I'm going to do this inside of the Jupyter Notebook environment because it's slightly easier that way. Jupyter Notebook. Boom. Good. So, visualization. Boy, my computer just not having it today, huh? All right. So let's say that you have data, you've acquired data, and the time has come to view that data in such a manner as it makes sense to people. There are a number of libraries for plotting data inside of Python. PyLab, PyPlot, Pandas, and the one that we'll be using in this course is PyPlot, or we'll be exploring during this topic. PyPlot is a sub-object, I guess you could say, of a larger library called Matplotlib. It has basic syntax, and it is also an object-oriented way of going about things. So, we'll use, we're just going to do the basics with this guy, but these graphing utilities can come up with some very interesting plots, which I will just jump to the end and show you some examples of what this is capable of. So, error bars, histograms, hex bins, box plots, 2 and 3 dimensions, the examples are limitless for the number of different plots you can produce. It's sort of, what do you guys use as a graphing utility? Do you guys use Maple? Do you use MATLAB? Do you use R? What do you use?
I've used just Excel and R is
Mm.
2 big ones.
Just Excel? Yeah. It's worth learning MATLAB, incidentally, or Maple, especially if you're in the sciences. If you're in the business faculty, then perhaps MATLAB is too much. But it's very scientific software, right? Now, I would totally recommend it for your own personal edification, but you know, it's going to be more than you need for a lot of things, and, you know, so MATLAB stands for Matrix Laboratory. So, you know, unless you're dealing with matrices. But anyway, so Matplotlib is an optional Python set of packages for plotting. It is pre-installed in Anaconda, so if you have Anaconda, if you have a local Anaconda distribution, you have this already. It's also been installed on Jupyter Hub, so if you'd like to log into JHub and try it that way, you're absolutely welcome. And these are installation instructions. If you have neither of those, basically if you've not installed Anaconda, then the likelihood is that you're running Linux and you installed it from the command line, in which case, there are your commands. So, you can get the plots from Matplotlib to show up directly in a Jupyter notebook using a Jupyter quote-unquote magic command, Matplotlib inline. Actually, you don't even need to do this. But, you know, Jupyter's actually got a lot of commands that you may not be aware of. It's also possible to get a debugging interface up and running inside of it. But, you know, most of the time, people don't. It's very useful in Jupyter to be able to enable line numbers if you haven't already. That's, I believe, view toggle line numbers. If you don't have that on, that'll help you find your errors. Anyway. So, let's take a look. So, import matplotlib.pyplot as p. This is the wrong graph, by the way. X values and Y values. So you need some data, right? Let's say X is equal to 1, 2, 3. Let's say Y is equal to 4, 5, 6. Pyplot.plot X and Y, and pyplot.show. There we go. Name error. Oh yeah, because I'm using P, aren't I? There we go. Bing, bang, boom. So, you know, by default we get a line graph. Just to demonstrate this works, I'll add another data point. There you go. Very, very simple. So, once again, it is not naming this variable x, which makes it the x values. It is the position inside of the argument here, or the set of arguments here, which designates it as x. I can reverse this graph by inverting y and x, right? So far as it goes. Good. Any questions about that? These can also be tuples. Question?
I was asking you what are the data types X and Y.
Yeah. Yeah, it's basically what it's doing is it's looping through the provided data structure and matching up the you know, the x and the y coordinates to produce dots, not all of which are visible, right? You can, if you want, turn this into a scatter plot pretty easily by just specifying scatter and that shows you the points a little more, explicitly as points, shall we say. Boom. Make sense? So, okay, that's good insofar as it, that's as good insofar as it goes. However, we also, in addition to being able to plot scatter points, we also have full disposal of the general purpose programming language at our disposal. So, we can also use math to generate functions inside of Python. So, let's say that rather than having x and y as these simple sets of values, there we go. Let's say that x is a range from 0 to, or from, say, negative, no, that doesn't work. Maybe it does. Negative 50 to 50. And then y is equal to, I always forget the list comprehension syntax. Yes. X squared, or yeah, why not cubed, 4x in, or I should name it something else, x vals, y vals, or x in x vals. Right. Oh, right. That would be the reason. There we go. So you can see this very nice graph on the range from negative 50 to 50, and we get this very nice cubic curve. So the question then becomes, all right, this is fine, but what if we want to zoom in on this graph, right? So let's restrict our input range. Let's say we're going rather than going from 50 to 50, let's go from 5 to 5. Notice the segmentation. Because we're not generating any points at a sort of sub-whole number level, the closer we get in this graph, the more polygonal this ends up looking. So what we need is essentially a version of the range function which can produce floating point numbers, right? Now, this isn't actually provided by default in Python, and it's a bit down the sides, but essentially, we define it, a function called frange. Oh, no. There we go. Frange, start, stop, step, and places. Place values. So, x is equal to start. We initialize an empty list while the rounded value of x to the number of places specified by places, number of place values specified by places, pardon me, is less than round stop places. L.append round x places and x plus equals step. At the end, we return L. So, we may then say, if we change this from range to f range and we specify a step interval of 0.1, for example, execute, get an error, invalid syntax, because of course I forgot the colon once again. There we go. You'll notice how much more smooth that is. We can even zoom in further now that we have something that generates it on a using floating points. Now this is like, in this particular function, it looks pretty much the same no matter how much you zoom in on it, just because of the nature of the function. But hopefully the decreasing, x and y ranges indicate what I'm trying to show here. Yeah? Good. Any questions about any of that? Good. So, we can do more interesting things too. Like, for example, I'm just going to do a slightly more interesting, complicated function. Let's say the math.cos x cubed on a range which is larger. So there you go. You can do all kinds of interesting, crazy things. Cool. So let me see. Cover this, cover this. Yep. So, from there, we're going to talk about the different types of plots that you produce. So I already talked about the scatter plot. The way that you use the scatter plot is by replacing the plot command with the scatter command. It turns out, let me just ratchet this down a bit. Maybe a bit more. There we go. So we get that. You can even plot multiple of these on the same plot. So y1, y2. If we plot y1 like that, and p dot scatter x vals y2 vals. Oh, I need to make a modification. There you go. You can perform scatter and line plots on the same graph. Just multiple invocations of the plot or scatter command. In fact, for every data series that you wish to plot, you should invoke a separate, you should invoke these separately. Although I think it might work if you just provide it secondarily. Let's see here. Nope. There you go. So one invocation for per data series, please. Good. So if your goal is to plot data represented inside of CSV files, the basic approach is not dissimilar from our approach to working with files in general. Of course, the first thing that you're going to have to do is open up the file and read the data in the manner that we had covered previously in the lecture. We then construct the x and y value data sets from whatever data is relevant in the CSV file. So there's an extra step. After you've acquired the data, placed it inside of a data structure, you then have to iterate through that data structure, acquiring the data that's relevant to plot. Maybe you're only interested in plotting the first column versus the 7th column, right? You have to go through and select that. Various libraries can be used to do this slightly more efficiently or automatically, such as numpy.loadText and pandas, and you can also load from a network file using the approach in previous lectures. So that is to say, it is possible, since it's CSV data, to use the URL lib module to load CSV data from internet sources, plot it automatically. For example, stocks, right? It's possible to acquire CSV data such as stock market information, and if you want to, you can basically have a script, a Python script running in the background that acquires these stock market data from an internet source that allows it, right? And then, you could have like an automatically updating ticker plot going. And you can do your own instead of having to rely on Google for it. So yeah, right? So, as a simple example, if we had a CSV file that contained the following, right? We open it in read mode as file handle. Rows equals csv.reader, all stuff we've done so far. X and Y values are empty lists. We iterate over those rows, appending to X values and Y values the values from the relevant rows, or the relevant values from the row, pardon me. pyplot.scatter, X values, Y values, pyplot.show, and you plot the CSV file. Bing, bang, boom. This isn't too bad, right, guys? And of course, if you have a header file, then you can load it as a dictionary, read it that way. Everything's cool. Everything's nice. Everything's cozy, as the kids say these days. Plots may be customized in a number of different manners. You may have noticed that the plot as given to you by default is somewhat sparse with respect to the information presented. By taking your pyplot object and calling various methods on that object, you can insert data such as what the title of the plot is, what the names of the x and y axis should be, axis upper and lower bounds, which is very useful for like panning, You can add a legend by using a list of strings where each string in the list is the legend name, like the name that you want to give to the data series. You can enable grid lines. You can, work with colors, line styles, marker styles, etc., etc., etc. There are lots and lots of different options. But let's use a couple of them. So, let's say, there we go. P dot title is number of kittens over time. P dot X label, number of kittens. P dot Y label, no, I'm sorry, X label would be time. Pardon me, what the heck am I doing? Time. And this is number of kittens. P dot legend. Maine Coon kittens and Russian blue kittens. There we go. P dot grid is true. True. There we go. I think I have to put the legend after the data has been entered. I think that's how that works. Yeah, true. There we go. So you can see that at time 3 we've got almost -1 Maine Coon cat. But there you go. You can add data to it, or you can add annotations. Yes. The more plots you use, the more colors it will bring in. Like it automatically cycles through a number of colors. It doesn't if you're using like a scatter and a plot, but if you use 2 plots, for example, then it'll provide different colors automatically. Question?
Can you set the colors manually?
Yes. Yeah, absolutely. Yeah. And I would refer you to the documentation. Yeah, you absolutely can set the colors. You can set the marker style, you can set the line style, you can do dotted lines, you can do thick lines, you can do thin lines, all of your basic standard formatting stuff you're able to do here.
The graphing, the visualization part is just very, very similar to R in like the sense that when you're writing the commands to actually like graph, to actually like use the graph, but for that, like reading the data is very, very different. It seems very tedious. R is it's a lot more automatic almost. It's just a couple of built-in commands. This is like you're doing it yourself. There's no sort of.
Well, I'm also teaching you how to do it yourself. Yeah. You can get more automatic ways of loading the data in if you're using some of the libraries that we don't really cover in this class, like pandas or Monkey. Actually, there's been some talk among the TAs that pandas in particular would be like a useful thing to cover in this class.
I think it would.
Yeah.
It's come up a lot when looking for just off of Google searches to get through the assignments and stuff like that. There's a lot of similar concepts have been from other people's code that you see online. Pandas is referenced a lot.
So I basically have 2 minds about it, right? It's like, in the first place, like this is intro programming, so you should be able to work all of this up from basic constructs, right? Not rely too much on other people's code. Otherwise, do you understand the code yourself, right? Because like we're trying to teach people how to program. It's like, there's a saying that a man can't serve 2 masters. And I think a course, like this course is like split in the curriculum that it covers, or it's split in its audience, but not in the curriculum that it covers to some extent. Like, there's a focus more on the shall we say, theoretical aspects of computation, because this course is designed for the comp sci program, and believe you me, the comp sci people absolutely need that introduction to, you know, algorithmic complexity and that sort of thing. Personally, I think it would be useful if the department were to sort of take one MD3 and split it and do almost like a scientific computation type course that could be geared more towards the
CS majors?
no, like the non-CS
Oh,
majors,
okay.
like people in the science faculty, you know,
Okay.
focus a little bit more on, you know, stuff like this, using pandas, all that kind of stuff that's like, maybe cut out some of the like theoretical computer science material and orient it more towards, you know, things which apply and are like, you know, things which are applicable more to the scientists and that sort of thing. You know, people who are interested in using computation for more practical, you know, let me at the damn library kind of applications. That being said, because of the current structure of the computer science program, this course is like people use this course in a number of different ways, right? It's like, as I found out, this course is used by the registrar to determine whether people are any good at comp sci and should be let into like the comp sci as a second degree program or the comp sci major program, right? So people, like, this course is very much used to access, you know, the harder, more abstract theoretical computer science topics. Therefore, it must serve that purpose every time it's offered. I can't just like, you know, I can't create two different courses and run different versions of it depending on who's taking it. You know, it has to be consistent and it has to teach the same stuff, right? And because it's, you know, this is the first year comp sci intro to programming course, you know, it is correct for it to serve the comp sci program primarily, even if by population it's primarily serving the rest of the campus. You know, but you know, that's sort of, if you're interested at all, this Wednesday there's going to be a departmental meeting on you know, continuous improvement of the curriculum in the CAS department. So if you're interested at all in showing up to that meeting, you can just email me. I'll let you know when it's happening. And I'll get you in touch with Wolfram. But you know, if you have some comments. But yeah, that's kind of the way it is, you know. But yeah, make sense? Yeah. Yeah. Anyway, so kind of did that. So I don't think this topic is going to take us the rest of our time today. We're definitely going to be moving on to databasing pretty soon. Next week is the last week of classes, right? Yeah, okay, good. Any questions about the exam?
Will it be covering data visualization stuff from here on out? Or will it be kind of like last semester?
Well, visualization is like notoriously difficult to test. So it's, you know, primarily for interest, shall we say. But yeah, at this point in the course, SQL is certainly testable. And we test it just about every semester. Machine learning is a topic we often don't even get to, actually. Because this is an offering where there have been, like, just generally not a lot of people in the class, at least not a lot of people regardless of how many people watch the videos afterwards, there's not a lot of people in the class to ask questions, and there haven't been a lot of questions that have been asked, which means that, the lectures haven't been taking as long as they usually do. You can probably attest to that. So we're probably going to be able to make it all the way through to machine learning, which is awesome because I think it's been at least 2 offerings since I've been able to cover it. So at least in any depth. So yeah, I think we'll be able to cover all of the lecture material for once. But yeah, anyway. In terms of what can be on the test from here on out, pay attention during the SQL stuff. But other than that, you should be focusing your study efforts primarily on object-oriented programming. That's normally a big topic. Yeah. Let's see, stuff covered since the midterm. The testing and exception stuff, particularly know how to work with exceptions. That's very important. You'll lose a lot of marks if you don't know how to do that. Well, I won't say that. You'll definitely lose some marks. It's easy to test testing, so to speak. All you have to do is throw a little sentence on the end of a question and boom, you're testing exceptions. Let's see. There was a floating point question on the midterm, which nobody attempted because it was the bonus question. So I don't know. We'll see how it goes. Expect object-oriented programming to figure prominently. Sometimes we do date time, sometimes we don't. It's one of those topics that it's small enough that, if we have an idea for a question, then we'll throw it in, but we don't test it every semester, but you should still know how to use it, Yeah. Does that give you an idea of exam coverage? Question? We'd have to draw it up first. We're still working on preparing it, so in general, the exam is going to be 2.5 hours instead of 1.5 hours. So, and it's going to be, well, it's an exam, so it's going to be more difficult than the midterm. So, that's, we'll see. We'll have to see. Again, we're still working on fine-tuning it, and yes, we know that everybody didn't do well on the midterm, but we have a certain standard to maintain. So we'll see how it goes. I'll probably be able to provide more intelligent answers next week. So any other questions about the final exam? Right, so graphs then. Histograms. So if you want to have data bucketed in a histogram, then you provide the data and you use hist instead of plot. Note the data does not require a x. It does not require x values because you just it's a frequency graph. So there you go. Bar charts does require x and y values. Rather than having points, you have vertical bars. If you want horizontal, you can do bar h. Very good. Pie charts. You have some data and some categories. It automatically calculates the percentage for you and gives you the slice of the pie accordingly. If you don't set the aspect ratio to 1, then you'll end up with an ellipse graph rather than a circle graph, which might be what you're going for, but probably not. You have to specify the categories as labels specifically, but if you follow this, then you will produce a pie chart. And I know how business people love their pie charts. We kind of already talked about this, but if you want to plot more things on one plot than just the one, this is the syntax for doing that with one call. Or you can just call plot twice, providing the x, y1 and x, y2 on different iterations. Make sense? You can also hook this up to date time using the xticks method. You can set what the values of the xticks are. Therefore, you can have this thing being plotted over a series of days rather than numbers, right? Note we are creating date-time objects and providing a list of those objects as the x values, and then plotting them. Make sense? Good, good. So this one's kind of cool. So thus far, we have we've only been displaying these images. We haven't actually been saving them to files. If you use pyplot.savefig and then choose a file name, that will create an image file with the plot that you have created. You can use a bunch of different file extensions here. It will read the file extension automatically and process the file according to the file extension you have provided. One important thing to note, you must not show the graph inside of the environment. Basically, whenever you show the graph, it wipes everything in the object. So if you show it and then try saving the figure, then it'll save nothing because you've already blown out all the data. So you replace show. Oh, no, stop. Get out of here. No. So rather than showing, p.savefig my pie chart, my chart.png, run that, bing bang boom, and if I take a look inside of the directory, you will see that the graph has been created. Now, for whatever reason, it has chosen to insert a transparency behind the chart itself. It's probable that you can configure the options, and that's not even a problem most of the time because you'll be putting it in a document with a white background or whatever. Or if you put it in a document with like a blue background, then this still shows up as white. But anyway, transparency layers. If you do it with a bitmap or a JPEG, then you wouldn't get a transparency layer like that. Let's do that. JPEG. See? JPEG, no transparency layer. JPEGs do not support transparency, but PNG does. So, good. And that's it. Any questions about graphing? No? Doing good? Excellent. Right. So, that being the case, we now move to our penultimate topic, databases. So, databases are kind of a hot topic at the moment. Knowing how to use database software is a, shall we say, highly employable skill. It's one of those things where, like, knowing, like, working with databases is, like, sufficiently difficult and tedious that you can't really, like, just pick it up if you know how to use a spreadsheet, you know? Like, it requires some degree of training and experience, but, you know, it's the type of thing people do for a living, you know? So, there are many different database types of database that you can have. In this course, we're going to focus on what is called the Relational Database model. This is, you know, I'm not going to say falling out of favor because it's very much still used. It's used quite prominently pretty much everywhere. There are younger, hipper database formats, the so-called NoSQL database, which has become, you know, increasingly popular. But, you know, it is highly unlikely that these new upstarts, these usurpers, will be able to unseat SQL for its primary applications for a couple of reasons. Number one, it's sufficiently good at what it does that it doesn't, you know, require that much modification, right? It's like the QWERTY keyboard problem. There are better keyboard formats available, but since QWERTY works well enough, then nobody wants to switch. The other thing is that these types, so one thing that you'll find if you go out into industry and, you know, talk to people who work in industry, there is a certain reluctance among people to give up their old technologies, if that makes sense. Generally, like, when you're young, picking up a new language does not seem like a big thing. You know, it's like, well, maybe it does, but, you know. Picking up new technology is kind of the purpose of your education, right? You want to learn the state of the art. People in industry are like, you know, someone in their 50s who's been doing this for 30 years, you know, has a particular way they like doing it, it works well enough, gets the result they want. They're less inclined to see the advantages of newer forms of technology, so they're more likely to continue using old ones. Not to mention, from a company's perspective, the senior engineers right most of the time. If benefit could be afforded by a new technology, you have to train everybody in the company to use it. That costs money and time. There are going to be mistakes made when you're transitioning from one system to another, right? And, you know, a lot of the time, especially for like very new technologies, the advantages of the technology are often, shall we say, exaggerated by the people who are selling it, right? So you could spend, you know, hundreds of millions of dollars converting your company to use some new technology, and it turns out to be worse than the old technology, which is old but reliable, right? Reliability is a super big concern in these types of situations. So, SQL databases are, despite dating back to the 70s, still very much in use today. Typical application of SQL database would be, it's the way that passwords on websites are most often kept. When you want to log into a website, the username and password that you have provided is structured into an SQL query, which returns either a true or a false result, depending on whether your username and password occur in the same entry inside the database, right? So, let's talk relational databases. So, like programming languages, databases allow us to process and store data. However, the data inside of a database is stored in a dedicated file and loaded as needed. The data can be much larger than the available memory. Unlike a general purpose program, if you're loading data into a general purpose program, all of that data must be loaded into the RAM, right? So the amount of data that you can load into a program is limited by the size of your RAM. Not true in databases. So again, the type of applications we're talking about here are retailer catalogs, bank accounts, personal records, all kinds of stuff. Generally speaking, relational databases operate on a transaction basis. So if a user wants to interact with the database, they construct what is called a query. They send that query to the database. The database then processes the query. If it has any result, it returns that to whoever sent the query. That might be viewing data in the database, for instance. But otherwise, it's an get in, get out transaction. You don't open it and you're not opening a file handle and holding onto that file handle until you're finished, like is the case with the file I/O that we've been talking about so far. Make sense? So, because of this transactional nature, databases can be accessed simultaneously, quote unquote, by clients either locally or remotely. So basically, if the database software is accepting transactions, it's accepting queries, it can accept queries from multiple sources, put those queries in a queue, and process them one at a time, right? That's kind of the idea. So if you think about, think about a large database, think about something like Facebook, right? Because Facebook posts are really just database entries, right? Do you have to lock every other Facebook user out of Facebook in order to make a post on Facebook? No, obviously not. Now, it gets very complicated at that scale, right? Obviously, there's no single computer that can contain everything contained in Facebook, right? You need many, many, many computers all communicating with each other, right? But, in general, the model holds in general. So data is updated atomically. Data is either stored or not, but never becomes corrupt, even in the case of failure, disk error, or network disconnection. So atomic meaning atomicity, meaning indivisible. An operation on a database which fails to update the database. So if, because, oh my gosh. When you're playing a video game and it's like you get the little spinning thing in the corner, and it's like, now saving, do not turn off the console, you know? Ever wonder why you're not supposed to turn off the console? It's because if you turn the console off while the thing is saving, you only save half the data, right? So the save file itself contains half of the data from your new save and half your data from your old save, unless it's got some kind of system in it, which preserves the old copy until the new copy is complete, and then it references the new copy and deletes the old copy at the end, right? But if data is updated atomically, then you don't have to worry about corrupt save files, basically. So, in a relational database, data is structured in very specific ways, specifically using tables and entries, basically analogously to any spreadsheet that you will have used so far in your lives. This is in contrast to the NoSQL databases, which are structured much more loosely, much more like a JSON file. Complex queries can be written in a dedicated query language. So the language that we're about to study, SQL, structured query language, is in fact Turing complete. So you can write entire programs inside of SQL. Because of the Turing completeness property, that also means that any Python program you write has, there is a corresponding program in SQL that you could write. The question is, how convenient is it to do so, right? How long would that program be? We're not going to be studying those types of advanced features of the structured query language. We're going to be studying how to write basic queries, how to perform basic database management. Any questions? No? Stop. So, relational databases. Inside of a relational database, data is stored in tables. The analogy in spreadsheets, you know how you have a spreadsheet, but you have a number of different spreadsheets because you got the tabs along the bottom, right? It's the same idea here. So in a relational database, you will have a number of different tables sort of floating in space. Right? The database itself is the collection of all of these tables, right? Each of these tables has a name and is accessed by the name. So rather than having this tab interface that Microsoft products are very, shall we say, enamored of, you get at the tables in a database by knowing the name of the table. So, we have table A, table B, and table C, right? Within tables, we also have fields and entries. In the same way that we talked about fields and entries inside of a CSV file. In fact, if you take a look at these, you will notice that there is a fair amount of similarity between these and a CSV file. So, rows are entries, columns are fields. Rows are also called records, rows, objects, and entities, as well as entries. Fields are called values, columns, or attributes, depending on the application. So, let us examine an example scenario. A video rental store. Our object is to create a database for keeping track of the information pertaining to the running of a video rental store. Not that video rental stores exist anymore, because, people, physical media is dying, basically, and that's a shame, because it gave media some kind of grounding in physical reality, and now, like, media is a almost metaphysical reality, which I don't think is good for it, or our conception of it, but, not to get too philosophical. We need to track three things about our hypothetical video rental store from the 1990s. Number one, we need to know what movies we have available to rent. Number two, we need to know who our customers are. Number three, we need to know which customers have rented which movies. So, to do this, we will make three tables: movies, customers, and rentals. Here is an example of the movies that we might have in our movie table. We'll be entering this data a bit later on, once we learn how and what, why, etc. So, a bit of nomenclature first, though. This first title row contains the field names. Inside of a relational database, each column is associated with one specific data type. You're not allowed to mix data types within a column, right? It's like, this is a number, and these three are strings, and that's all they can be. If you want to put a number in here, you have to make it into a string, and you can't put a string here, I know that sounds like a very basic thing to know, but in Python, everything's loose, right? You wouldn't have these types of restrictions. But in SQL, it will definitely prevent your transaction from occurring if you violate the type system. So, the types which apply to the various fields of a relational database table is known as the schema. The schema gives you what type applies to each field. The valid types inside of SQL, this is a very incomplete list. Integer, real, text, Boolean, and date, corresponding to integers, floating point numbers, Unicode strings, Booleans are Booleans, and dates can be stored as either a numeric value or as a string. So it depends on the vendor. So in this case, our movie ID is an integer, title is text, genre is text, and rating is also text. So let's talk about SQL. SQL is the structured query language. It is quite widely used, so it's useful to learn. It was first proposed in 1974 for Codd's relational database, our relational data model from 1970, and can be used to yes. Okay. Sorry, the grammar escaped me for a moment. SQL can be used to interact with SQL databases. SQL cannot be used to interact with non-SQL databases for obvious reasons. You can use SQL to fetch a set of records, add data to a table, modify data in a table, delete data in a table, add tables to a database, add entries, add columns. Basically, you do everything with SQL. The syntax is mostly independent of vendor, but We don't even know what it means to say vendor yet, so we'll get there. SQL will also support transactions such as begin, commit, and rollback, authorization, stored functions, and more. SQL is more general than these examples suggest. The results of an SQL query may be used as the input of another SQL query, so you can pipeline SQL queries. And, of course, recently, NoSQL databases have become popular. So, let's talk about vendor. So, this kind of gets into the manner in which software companies used to exist. These days, things are a bit different. Because of the mainstream adoption of the open source movement, this is not so much the way that things are done these days, although this does persist to some degree, what I'm about to describe. Back in the day, when you wanted to create a new language or style of software, the first thing that you would do is you would write a specification. This specification document would not be made publicly available. The specification document, well, except in, you would have a choice as to whether or not to make it public, right? If you did not make it public, then the expectation is that software companies would license the specification from you, right? And you would make money. These software companies, which licensed your specification, would then themselves create an implementation of the software described by the specification. Because it is, because you would often license your language to multiple companies, each company would come up with their own implementation of that software. So, specifications can be either like more or less constraining, right? But in general, the less constraining the specification is, the more is left to the individual company to add their own features or distinguish their own product in one way or another, right? This is the same process by which the C compilers, the various C compilers, came into existence. There is a C specification. The GNU Foundation, which writes a lot of Linux software, came up with their implementation of the C language called GCC, which is the GNU compiler collection, which is, basically that's like the standard, that's like everybody who knows C programming has probably used GCC. IBM has their own implementation of the C language called Clang, or C-Lang. Microsoft has their own implementation of the C language, which I think they call Windows C. Incidentally, GCC and Clang are both compliant with the latest version of the C specification, but Windows C is not. So if you are taking 1XC3 with me next semester, you have to be careful to use a C compiler which is compliant with the C specification, or else you might be writing languages that are not even valid C code according to the C specification. But anyway, each one of these companies has a slightly different version of the C programming language, but so long as it's compliant with the specification, the same C program should have a reasonable degree of compatibility across C compilers. Now, that's not always the case, because some like one of the differences between GCC and Clang is that some things which GCC considers warnings, Clang considers errors. So a program that will compile with warnings under GCC may not compile under Clang. Clang is slightly more restrictive. So, you know, so it goes. But in general, if your C program is correct, that is, it doesn't return any errors or warnings, then you should be fine compiling it in either GCC or Clang. Fine, good. C has a very specific, like has a very well-specified specification. There's not a lot of wiggle room inside of the C specification. There is much, much, much more wiggle room inside of the SQL specification. Lots of people have their own implementations of it, and these implementations can vary quite widely. Oracle is a big, that's a big software company. I believe they're related to the Java programming language. Maybe they made the Java compiler, I can't remember. I can't remember if that's Oracle or Sun Microsystems. Anyway. Microsoft SQL Server, right, that's another one. These are commercially available. You also have a number of open source implementations of SQL, such as MySQL, MariaDB, PostgreSQL, Sqlite, which is what we'll be using in this class, and MongoDB. MongoDB is not an SQL database. That's one of these non-SQL databases. It's JSON-based. So, most use SQL for interacting with databases, although some have slight differences. Okay, so I have presented you with a list of SQL programs. So what's the difference between all of them? These guys will often have made independent design decisions about things like what the valid data types are. How are those data types stored? Are dates and times stored in string format, or are they stored in integer format, right? These are the types of design decisions that these individual companies will make. Although, you know, it's kind of like you could make it work with any of them, you know? But it's like, you know, maybe your company has some application which needs one specific feature over another, so you want to use this type of database versus that type of database. Generally speaking, if you know how to use SQL, then you know how to use any of these. It's just a matter of like adapting what you've learned a bit to the software that you're now using, right? Good. So let's talk about Sqlite. Sqlite is a widely used serverless relational database manager. So many of these databases, you set it up on a server, people log in, people add data, people take data away, you know, it's a web interface. What Sqlite does is it takes SQL and allows you to perform it locally on your own machine. This, of course, completely handicaps it with respect to, you know, typical database applications, right? Because it's serverless, you can't get multiple users, right? But, you know, insofar as it's useful to have databases going on locally, Sqlite is one way of doing it. The reason that we're using it in this course is because it's simple to get, simple to install, simple to run, and it allows you to perform SQL queries on data without a lot of the, you know, difficult setup. So SQLite is pre-installed on Mac and Linux, well, certain types of Linux anyway. It also comes with Python, and it can also be downloaded at sqlite.org. So are all of you Windows users? Windows, 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 Mac? Yeah. So you're fine, you don't have to do anything, but the rest of you will have to download and install Sqlite. So, let me just, where's the, okay. So let's grab this then. Sqlites.org. So this is Sqlite. If you want to get, oh, there we go. If you want to get it for Windows, you're looking for the precompiled binaries for Windows because you probably don't want to compile it yourself. I don't even know what language it's written in. What you want is Sqlite tools-win32x86 version number. A bundle of command line tools for managing Sql database files, including the command line shell program, the sqldiff.exe, and Sqlite 3 analyzer.exe. The one that we're interested in is the command shell, command line shell. So this is a command line tool, so for Windows users, this will be running inside of Windows PowerShell, which all of you should have. Good. So basically what you're going to get here is you're going to download a zip file. Once you unzip that zip file, you will get 3 executable programs inside of it. There will be Sqlite3.exe, and then these two guys, you'll want to run Sqlite3.exe. That will bring up the command prompt, and then we can get to work. For me, all I have to do is run it from terminal because I'm Linux and I'm cool like that. Sqlite 3. Boom! So, creating a database file is as simple as saying .open and then picking the name. We'll call it videostore.db. There we go. We have database access. If you want to quit, it's .quit. The kind of meta commands, I guess you could say, like opening, closing, saving, quitting, all start with period. So there you go. SQLite 3 videostore.db. There we go. So the first thing that we need to do is to create the table, because this is a blank database. It doesn't contain anything yet. .tables shows you the tables. It doesn't print anything. So our command for creating tables, create table, you pick the name of the table, and then you provide the schema. Movie ID, integer, title, text, genre text, rating text. All SQL queries are terminated with a semicolon. I know that you have picked up the bad habit of not terminating lines with semicolons from your Python experience, unless you have experience in better languages. But when you're programming in SQL, you must provide a semicolon at the end of each statement. So, create table movies. ID. No, I'm going to stick to it. Movie ID. Integer. Title. Text. Genre. Text. Rating. Text. Boom. Dot tables. We now have movies. In SQL, the keywords, highlighted in green, are not case sensitive. But any any name that you have provided, such as movies, movie ID, title, genre, and rating, those are case sensitive. So be aware of that. So this is good so far as it goes. However, there are a few options that you can provide at this stage, which they work to ensure the soundness of the data that's inside the database. So, in the first place, we might observe from our application that we shouldn't have any movie in our database that does not have a title, right? Now, it is possible that we don't have a rating for a movie, you know. There are unrated movies. It is also possible that the movie is such a work of eminent genius that it breaks all genre boundaries and is its own genre, which cannot be categorized in any other way. That is also possible, though unlikely. So, but title, every movie should have a title. What we want to do is we want to make the title of the movie required. Further, the movie ID is a unique identification number which all movies should have in our database. This is how we're going to refer to these movies outside of this table, right? So, we also want to make the movie ID required. Not only do we want to make it required, we want to make sure that no two entries can have the same ID, right? In SQL terminology, we want to make the ID number a primary key. So, I'm just going to delete, drop, table, movies, which deletes the table and everything in it irrecoverably. So, you know, that's the atom bomb of SQL statements. I only did it because I get to, you know, I get to trace through my command history. Oh, if you're ever like doing anything inside of a command prompt or a command line interface, using up and down arrow normally lets you scroll through previous commands, and you can modify a previous command and run it again. And that's like, if you don't know that, you're going to take like 5 times as long to do everything. So, important to know. So anyway, create table. We will say that movie ID is an integer and also a primary key. And we'll call it required as well. And title, text, required. Oh, I guess you can't put required. I guess required is implied by primary key. There we go. There we go. So it goes. Good. Any questions so far? Good. So, now that we have a table, we need to take data and put it into the table. So, the command for that is insert into, and then you specify the table name. Then you specify the values that you wish to insert. So, for example, insert into movies, values, 101, Casablanca, drama, romance, parental garbage. There we go. So if we view our tables, we still just have the one table. And I'm just going to, I'm going to skip ahead in the slides a little bit and do the command which shows you the table. Select star from movies. There we go. So you can see the entry has appeared in the database. So let's try to break it. How about our next one, our next movie? Back to the Future, which is a comedy adventure, also rated practically garbage. I mean, that's a good movie. I like that movie. But you know, that's what people say about PG, right? Anyway, this transaction has failed because we have failed the unique constraint on movies.movieID. I did not update the movie ID. So because this matches an ID that's currently in the database, this has failed. And if we view the database, you'll notice that the transaction has simply not occurred. If, however, we modify this, pop that in, you'll see that Back to the Future has been added to the database. Good. So, some of you may have noticed a slight difference between the manner in which I have performed this query and the manner in which it has been laid out in the slides. Incidentally, these two lines constitute one command because the semicolon is at the end of the line, right? Not at the end of this line. So it's a command up to and including the semicolon and no further. So the way that they're doing it here is insert into movies and then providing all of the field names and then saying values and the values for those field names. That also works, has the same effect, right? What that's good for is if you have incomplete data. So let's say, just for the sake of argument, that our next movie, insert into movies, values Monsters Incorporated, which is a animation comedy. Let's say we don't have a rating for it. What you do is you provide a schema that contains the elements that you do have in the order that you have them. So, in this case, it'll be movie, ID, title, and genre only. Unique, poop. Did that twice. There we go. Now, if we view this, you'll notice that rather than having a value specified for the rating, we just have a blank, right? Now, it's a little bit deceptive because, you know, if I'd picked this one, we would have had two bar characters and then the next thing. Because it's at the end of the line, it looks a little deceptive, but, you know, it is what it is, I suppose. Good. Make sense so far? Okay. I'm just going to take a brief moment and enter the rest of these because they're important for our upcoming examples. So, insert into movies 104, Field of Dreams, which I think is the only movie on this list that I haven't seen. I don't even know what it's about. PG. There we go. Oh gosh. $57.93. Life of Brian. Comedy, rated R, because it contains actual nudity, although in a very perfunctory sort of way. 7442. 12 Angry Men, which is a courtroom drama, although it doesn't actually occur in a courtroom. PG. There we go. If we view our data now, you'll see that we have all of our fields populated. Ta-da! So much for insertion. We've already used the select command to a certain extent, but it has, pardon me, it has a number of options which it's important to review. So, when viewing information in a database, it's not so much that you're, calling data out of the database. You should think of it like constructing a view of the data, right? You're creating a way of looking at the data, right? So, let's go through this in detail. The select command is necessary, that tells us that we're viewing data. From indicates which table we're viewing the data from, as you might expect. Star is a wildcard character. It stands for all. So select all from movies. If you want to restrict your view to only specific fields within the table, you specify those fields which you want to view. So, if you want to just view the title and rating, for example, select title rating from movies. The list that is returned contains only those values. You can also restrict your view according to generalized Boolean expressions, otherwise known as filtering. So those database entries which match the Boolean expression will be displayed and the rest won't. So, for example, select all from movies where genre is equal to comedy. If we add where genre is equal to comedy, we get only that entry which has comedy as its genre. Make sense? Any questions so far? The stuff isn't too bad, right? Like SQL is not difficult, but you do need the introduction to it, right? Presented with the command prompt, it's likely that you'd have no idea what to do with it, but once you get going with it, it's not too bad, I think, anyway. So, you'll notice that when we select comedy as the genre, we are only matching Life of Brian. We're only matching that field which has specifically only comedy as the genre. Other movies in the list also have comedy contained in the genre. So this should tell you that using this formulation, we're performing exact string matching, right? However, we can also perform what's called fuzzy matching. So if we want to get all database entries where comedy is contained in the genre, we do it like this. Instead of using the equal sign, and incidentally, notice that that's a single equal sign, not a double equal sign, right? You write like, and then inside of this string that you're matching it with, you are now permitted to use the %sign character, which is a wildcard character in this case. So %sign basically will match any number of characters that's not, the next character adjacent, right? So if I provide a %sign at the beginning, it matches all those movies where comedy is either the whole thing or at the end, right? Because in this case, animation space matches the wildcard character. If we provide the %sign at the end, of course, we get the opposite. We get all of those movies which start with the word comedy, which is in this case Back to the Future. Space Adventure is contained in the wildcard. And if we provide both as so, then we get both. We get a set containing all of the elements of the previous two queries. So that's fuzzy matching. Make sense? Any questions? That is often tested. Just going to throw it out there. So in addition, we can also order the results that we view by adding an additional clause, order by, pick a particular field, right? In this case, title, and how you want to sort them. Ascending, descending. There you go. Cool? Make sense? Any questions? No? Yeah. So. Yep, good. So, all right, so the next thing that we should be talking about then. So we have a rudimentary understanding of how to work with SQL databases. How do we hook this up to Python? Well, it turns out that there is an Sqlite 3 library for Python, which does exactly that. As you might expect, we're using a library. So, of course, we need to specify the name of the database file which we are trying to connect to, but the basic pattern is very similar to file I/O, although it's got a few unique differences. But you open the database to get the database handle, you perform operations on the database using the database handle, and then you close the database handle when you're finished. So, let me just quit out of this. There we go. And get it, SQL stuff.py. First step, of course, is to import Sqlite 3. Next, we open up and create our database handle. db dot, or is equal to Sqlite3 dot connect to, oh, I might have named it something slightly different. Let's see here. Yes, I capitalized it. Video store dot db. Then, when everything's finished, db.close. So far, so good. When converting from, or when reading data from a Sqlite database into Python, the following type conversions are applied. So I know we didn't talk about the null type, but when I failed to enter data in that one data entry, what was created was a so-called null value. In Python, that is interpreted as a none type, which is basically Python's null type. Integers become ints, reals become floats, text becomes string, and dates also become strings. And if they're strings and they're dates and you want to make datetime objects out of them, what method do you use? strp time from previously in the lecture. Yeah. I know it was a couple of hours ago now, but you know. So, so now that we've connected to the database, the next step is to create what's called a cursor. You can think of this as producing an instance of the command prompt it's like an invisible little command prompt. It's an object in Python, but it basically performs the same function as the interface that I was using from the command line. So we say cursor is equal to database.cursor. We can then execute commands through the cursor by saying cursor.execute, specifying a SQL query as a string. So cursor.execute select star from movies. Boom, 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 boom. There we go. Once this has occurred, once you've done this, right, the cursor object itself will store the results of any operations which have results, right? Like insert operations don't return anything, but select operations do return the data that has been requested. So it's contained in the cursor object. The way that you get it out is either cursor.fetch1 to fetch one record or one entry out of the database, or fetch all to fetch all data out of the database. So let's see what that looks like. Pretty sure you can use for loops as well. We'll see this later on, I'm sure. Fetch one. Cursor.fetch all. So let's run this bad boy. There we go. So, in the case of fetch one, the first entry in the database is fetched as a tuple. When you fetch the rest, right, fetch all fetches the rest, however many elements haven't been read yet, we have a list of tuples representing all of the remaining entries in the database, which, of course, since it's a list of tuples and it's now in the Python environment, you can perform whatever kinds of math or manipulations or, extractions, whatever you want. You now have the full capabilities of the Python programming language at your disposal. Write it into a CSV file, graph the data, anything you want, really. Make sense? Good. Yes, here we go. You can also for loop through the results, as you might expect. So when you, difference though. The return result of calling the execute method is that data which the execute method might return. So if we capture it, say x is equal to that, and we say for row in x, print x, it almost has the same effect. We have, wait, am I printing it correctly? Let me take a look here. What do I do? Print x cursor, yes. Okay, Let's try tuple casting it. Oh, no. I know what I did. Row. There we go. Everything's cool. So, notice the Null Type. Good. Any questions? It's reasonably similar to reading from a CSV file. It just requires more setup. Incidentally, so long as this program is executing and the database has not been closed, it will have, in this case it actually does lock the database. So if I tried to access it from terminal, I wouldn't be able to. Python has declared exclusive rights over the file. That's how it works with Sqlite 3, but not with other database software. Good. Yeah. If we add this row, the rows we get back will be dictionaries rather than tuples, and you can pull fields out by name. db.rowFactory is equal to Sqlite3.row. That extracts the row, the field name information from the table and produces dictionaries instead of tuples, if that's what you're into. Okay, I think I'm going to end the class here. The next topic is going to take a bit, so yeah. Any questions before we break for the day? No.
Best way to practice SQL, because I don't think our last assignment has it.
So if you look at W3 schools, it has some SQL practice. I'll talk to the TAs about it. We have like maybe we can release some like SQL problems from previous exams as like a special little package. Yeah?
Yep. Thank you.
Okay, cool. All right, get out of here. Get lost.